Tom described the high-level view of the open applications platform. And the key part of open application platform is the approach to composability, to composition. And I'm going to introduce Aquamarine, our approach to composition from the technical perspective. So first of all, a short design overview of the Fluence network. What do we need to have to build an open applications platform? First, we need to run services on some peers, on some machines. To do so, we developed the Fluence compute engine that runs WebAssembly packages and can access internal resources or external services. Then we need to compose these services secure way, reuse services and data. This is solved with Aquamarine that I will be talking about today. Security should be backed somehow. We have signatures, cryptographic relations, and a DPKI infrastructure implemented as a trust graph. Then, if we have services and resources and peers, we want to route to them and to find the resources. It's implemented with Kademlia and DHT in Fluence. Here we have Kademlia star and DHT star because these algorithms are augmented with the trust graph for better reliability. And finally, we need to have a blockchain for licenses and payments. But today, I will speak about composition. What is it? What can we want from composition? What behaviors should be available? So, for example, let's imagine the client, the web browser, that wants to do something, to use many services and compose them. First of all, it goes to a Fluence node that is connected to the network. Then it's very natural to move computations to some other node, other peer, to call a service here, to call a service function, and to have the result. So we have the sequential computations here. Then it would be nice to use this result as arguments on other peers to call different services in parallel. And if we have parallel execution, then it would be nice to aggregate the results of computations on some other peer and to call a function to aggregate with all the results of the previous steps. It's possible that the peer fails. The function may fail or the peer could be unavailable. And in this case, there should be a way to recover because it happens in the real world. And the recovery essentially is a part of a more broad problem of branching. So if a service failed, or if a predicate doesn't hold, then we want to do another thing, like move execution to another peer or try another service. And that's branching. So Aquamarine is the composability medium that makes all of this possible in the open network. So the developer can express choreography in a script, something like this, to do some steps in the network, get the results, call functions. The script and the data is being moved from peer to peer in a single-use logical network. So these peers, these services coordinate on a single request, forming a logical network that disappears when the request is handled. And finally, services provide Merkle proofs and signatures for their responses, and all the proofs are checked on the way. For the developer, it looks a bit different. So here's an example of AIR, the low-level language for Aquamarine. Here we have sequential computations, calling functions, doing parallel execution, and joining finally. So that's what under the hood. So to sum up, Fluence develops the open applications platform, which consists of several parts. We have Aquamarine as the composability medium that controls and coordinates data transfer and execution transfer from peer-to-peer. On every peer, we have the Fluence compute engine that runs services compiled to WebAssembly. It uses interface types and multi-module linking under the hood. And finally, Fluence is everything together, combined to form the network. Blockchain is not yet implemented. We are planning to use a substrate for it, but it's to come later. So I'm ready for the demo. Evgeny, do you want to add something?
Yeah, just to sum up what Dmitry was saying about Aquamarine. Aquamarine is essentially the analogy of Kubernetes, let's say, like a scriptable analogy of Kubernetes, where we can have the scripts that fly over the network and bring data with them among services and essentially coordinate how business logic is designed between different services. Services run on WebAssembly, and all of this has security, like all decentralized required stuff like Kademlia and DHT to work as a public and secure network instead of just like how it works in private setups.